So let us draw a voltaic cell. Remember, a voltaic cell generates electricity, and we're going to be using zinc and copper. The full reaction looks like this. Okay, let's try to understand what's happening here. So in the beginning, we have zinc right here. So zinc is turning into zinc plus 2. So let's go ahead and draw that. So I have two beakers here. I have some water in the beaker, and I'm going to put some zinc solid. This is zinc right here. And I'm going to give away, to become 2 plus, I'm going to give away 2 electrons. I'm going to give away 2 electrons. I'm going to make it move to the right over here. 2 electrons. And as zinc gives away 2 electrons, it's going to turn into zinc plus 2. And what's happening there is the zinc is going to dissolve, so this will be smaller. Maybe this is all gone, as zinc turns into zinc plus 2. So you're going to see a whole bunch of zinc plus 2 here, even though zinc plus 2 has no color, so you won't be able to see it, but it will be definitely present in there as it gives away electrons. Now, in order for this to happen, it can't happen on its own. There has to be something on the right side to take in those electrons, okay? So what I'm going to do is I'm going to go ahead and attach this wire to an inert solid. An inert solid means it does not react, okay? So this solid can be titanium. Sometimes they use titanium. In this case, we're going to use copper solid. Okay, it doesn't matter what it is, as long as it's conducting electricity. So, attached to another metal so that it can conduct electricity. What we're going to put in this beaker, though, is we're going to put some copper plus 2 ions. Now you might wonder, well, you have copper here and copper here. There's no relationship. I just used copper just to make it easy, okay? We are going to react with a copper plus 2, okay? Here you can see the copper plus 2 here is turning into copper 0. So the copper plus 2 is turning into copper 0, solid. Okay, to do that, it must take in 2 electrons. Okay, so what's happening here is that electrons flow this way. The copper plus 2 takes in 2 electrons as it turns into copper solid. Okay, so as these copper ions take in the electrons, it'll be gone. But they're not gone forever. They turn into copper solid as they build up on the outside of this inert metal. So the dots that you see are copper solid that's forming. So as you can see here, that black stuff that you see there, that's the copper solid. Okay. Let's go ahead and label these 2 cells. Okay. It's called the voltaic cell. This is a cell, and this is also a cell. The beakers are cells. Over here, as you can see, zinc. What happened to zinc? Did it get oxidized or did it get reduced? You're right. Zinc got oxidized. This is where oxidation occurs. Something stole the electrons from zinc. Who stole the electrons? The copper plus 2 ions, right? So as the copper plus 2 ions takes in 2 electrons, the copper plus 2 got reduced. Pause the video and make sure you fully understand that. Okay, zinc gave away electrons, copper plus 2 took them, so it got reduced. So now, this is oxidation. Wherever oxidation takes place, we call this the anode. So this is the anode. Okay, and this is the reduction. We're going to call this the cathode. Okay, so here's some ways to remember it. A and C and O are both vowels. Cathode and reduction, C and R, are both consonants. So that's how I remember it. Okay. Another way to remember it is that electrons always go from the anode to the cathode. It goes to the right this way. Okay. So the way I remember that is A, B, C, D, E, F, G. A goes first in the alphabet. It goes from A, electrons go from A to C. Okay, next. We are going to assign this electrochemical cell a charge, okay? So let me show you what they have assigned it. They're going to assign, this is called the electrode, okay? This is an electrode. And this is also an electrode. The metal piece. This is the anode electrode. This is the cathode electrode, okay? The anode electrode, they assigned to have a negative charge. And they assign the cathode to have a positive charge. So I'm going to put it outside as well. Okay, and let me tell you how I think of that. So here, negative, the way I remember it is where electrons are coming from, so it's negative. And here is positive, where electrons are attracted to, is attracted to the positive. So negative to positive. Okay, and I think I did my battery here incorrectly. So this is where electrons are coming from, so this should be negative and it's going to the positive. Okay, got that? Next, if you look at the circuit right here, or this electrochemical cell, the electrons are going to one side, but there's no way for it to go around and around in a circle or to complete the circuit. So what we will do is we will place a little tube. So imagine a tube. Inside that tube, we're going to put some substances, okay? Inside the tube, we're going to put a gel. So we put a gel so that it doesn't spill out here. But within those gel, we're going to put some ions. We're going to put a salt, okay? So a salt is composed of positive or negative ions. We can use something inert. We can use potassium nitrate, let's say. Okay, potassium nitrate has a K+1 and a -1. The reason we do that is because a salt will conduct electricity. And the reason we need to conduct electricity is because we need the electricity to flow around and around to complete the circuit. Okay? Therefore, they call this a salt bridge, because there's salt inside it. Okay? So the salt bridge conducts the electricity. It completes the circuit, number one. Number two, it completes the circuit. And number three, it will prevent charge buildup. And let me tell you what I mean by that. Prevent charge buildup. Okay, so let's look over here on the oxidation electrochemical cell. As zinc turns into zinc +2, we have a buildup of positive charge. Positive charge builds up as zinc +2 is made or is produced, right? Do you agree with that? So you're going to see a buildup of positive charge. You don't want that in an electrochemical cell. You want this to be pretty much neutral, okay? So if there's a buildup of negative charge, what this will do, what the salt bridge will do, is do you see what will counteract the positive charge? The nitrate, that's right. So the nitrate will travel this way. It'll go through this bridge. It'll come out here. Now the gel's not coming out, it's just the nitrate salt, okay? Oops, sorry. NO3 minus. The nitrate will flow out, and what that does is it'll prevent this cell from becoming too positive. Okay, so you have a positive charge buildup as zinc plus 2 is produced. So nitrate, or whatever negative ion you have in your salt bridge, will go in to neutralize the solution. Okay, so what do you think will happen on the right side? What is building up there? On this side, what's happening is the copper plus 2 is getting crossed out, right? Because it's turning into copper solid as you see it building up here, right? So what you're seeing here is a lack of positive charge, right? So you're getting a negative buildup. So you have a lack of positive charge as copper plus 2 turns into Cu0. A lack of positive charge is the same as a buildup of negative charge. Negative charge. So what do you think will happen to make this neutral? That's right. The K plus will go to the right. K plus, K plus, K plus. As it comes out here, so now it'll neutralize it. So the positive ion in the salt bridge will go in to neutralize it. To neutralize the solution. Okay, so this is this is an electrochemical cell. An electrochemical cell has the anode, the cathode electrodes, it has the two metal pieces, it has an oxidation, something that gives away electrons, reduction, something that takes the electrons, a salt bridge, something that has salt inside it, or ions that will neutralize the solutions and also allow electricity to go around in a closed circuit. Now you might consider, this is a lot of information. How do we communicate this with others, or a way of writing this, or a notation? There's a notation for this electrochemical cell, and again, a notation is just a label, like a way of writing. The way they do it is they start in the beginning like a story. In the beginning, there was zinc solid, okay? And then you draw a line. The zinc gives away 2 electrons as it becomes zinc plus 2, right? Then, and this is aqueous now, the zinc turns from solid to aqueous. Then there is a salt bridge as it travels to the other cell. So this little double line designates 2 different electrodes and also separation by the salt bridge. Inside the other electrode, there are some copper plus 2 ions that takes in the electrons. They used to be aqueous, but as the electron is taken in, it is now a solid. Okay, so this is the cell notation for this galvanic or voltaic or galvanic cell. Okay, let's try the sample exercise. It says, indicate the reaction occurring at the anode, the reaction occurring at the cathode, direction of cell migration. Okay, I think I will make another video for this. It might be a long time. It might take us a long time. I'll stop here.